Hello everyone, welcome to the webinar. I'm Ari Helchak from Root Signals. I'm going to talk about the top 10 misconceptions about LLM charges in production, and I will cover the first half of the webinar, and Oz from Root Signals will cover the rest of this. The reason I'm possibly justified to talk about this topic is my experiences ranging all the way back to 2005 when I started dealing with probabilistic inference systems. Then wrote a book on the theory of truth in the context of mental models back in the day, and then over the recent years did my PhD on generative AI, and for the last 1.5 years I've been the CEO of Root Signals, where we focus every day on the topic of LLM evaluations on the context of specific business tasks. Before jumping into the misconceptions, let me first give a brief intro of the background that you might need if you are not daily dealing with these topics. So firstly, why do we need to do anything? What is wrong with LLM automations? So whether we're talking about agents, chatbots, or automations running in the background powered by large language models, we are talking about non-deterministic systems, simply due to the architecture and training methods that are being used to create these models in the first place. By the same architectural and training constraints, these models are completely lacking any kind of self-reflection. They have no idea what they're saying. They can always go back if you ask them to, or if you create agentic mechanisms to go back and forth. But the models themselves, they just can't do it. At least not the large language model architectures based on traditional transformers that we have accustomed to so far. The other aspect of this equation is the semantic guidance. So when we are talking about human language and guiding them to human language, it's really not possible to give the same kind of precision guidance as with software programming in the traditional sense. So this leads to the failures that we are pretty much familiar by now, most famous being hallucinations and inaccuracies, and various interesting kinds of biases, and also interesting ways in which, for example, chatbots can diverge from the business interests of the people who created them, including some catastrophic answers to user questions, or annoying answers like recommending your products less than the products of your competitor, which might not be something you actually want to have to happen. So this is essentially a multi-dimensional failure situation. You have many different ways in which the models can fail. And then why do we need to do this evaluation in a different way than how we do traditional software testing? So firstly, we don't know always what is the expected answer to a specific input that the user is going to say. We don't even best know what the input is going to be. Actually, usually we do not know, and we might have a range of expected answers. So these are open-ended systems. We cannot test them with just looking at the output as a simple string comparison or even like some kind of subset comparison. Also, we cannot just rely on generic benchmarks for evaluating large language models or all across the board. Instead, we need to look at task-specific tests. And this means that we need to specifically look at how they perform for a specific task that you are interested in, and not across every possible task on that domain. One source of confusion is the difference between capability assessment and optimization. So often people are very interested in what is the maximum thing that you can get out of the model. Can you actually make it do that most complex possible thing conceivable? Whereas in practical terms, you are interested also in costs and latencies and sizes of the models, and often you also want to be using even open source models running on your own hardware. So this becomes necessarily an optimization question and not a question of whether the best possible model could perform your task or not. Finally, what we are actually looking for in terms of defining what success means, we are talking about semantic measures. So hallucination avoidance is at a whole another category of things, than cost and latency. In order to even define the problem, you need to define it semantically. That means in terms of human language. So you need to think and to understand, in a sense, what hallucination means. What does conciseness mean? Concise doesn't mean short. What does helpful mean? So these are semantic measures, and they are very different from cost and latency, which we also need to optimize for. But these are two different levels of testing for things. So when do we need to use LLM as a charge, as a technique? Consider the case of, for example, what we have as one of the typical ways to use root signals platform, where you can create this sort of metrics that are of semantic nature. Typical way to do this policy evaluation of chatbots is by using charge LLMs. So if you want to check, does your chatbot actually align to what you were trying to make it the way you were trying to make it behave, according to your communication policy, according to the general rules that you have defined in your organization, or for that specific use case, you need to use another charge model or a human being to actually evaluate whether your chat was doing the right thing. There's just no other way. So in essence, whenever we talk about these kind of problems, we are talking about a situation where the model is expected essentially replace the human who would otherwise be doing this kind of judgment. Basically judging, is the output following the said policy or not. This is just a typical way to measure a complicated emergent or at least semantic level of what the model is actually doing. And in practice, the results of this evaluation will determine if that chatbot output was actually according to your expectations. This applies also to any other kind of complex behaviors, like let's say you are comparing large documents and you want to know if the LLM that compared to documents actually behaved in the right way. Again, you need an LLM. You want to look for proper tone of voice. Again, you need an LLM to do that analysis, and so on and so on. So now let's dive into the actual topic, the misconceptions, where we are going through various ways of thinking that we have found people to have, and what we think are the contrastive claims that we believe to be true about LLM charges. And we will be also dropping some nuggets of our own research that actually supports these claims, and also with some references to existing research that we are continuously studying on the side. So misconception number one, the most often heard: anyone can make a charge because you can just prompt that into an LLM. So basically, you can ask the LLM to take this piece of text and say that, okay, what is the quality of this text? Give me a number between 0 and 1, or 1 to 10. And it will give you, with no effort at all, it will give you 0.7 or 7 out of 10. And then the problem is that when you ask it the next time on another text, and it will give you 0.2. And then you have like this number. So what does it mean? Was this consistent at all? This is by more often than not, it is not consistent. So even with the same model, and slight change in the prompting could also make a difference here. So the problem is deceptively simple, but in fact, making this consistent can be very, very complex if you're just looking at this for the first time. Moreover, there's a lot of research on how actually improper use of prompts, or even just sort of specific ways to use prompts, which we would as humans consider fairly perfectly fine prompts, can actually create or result in more of certain subtle biases than the other ways to prompt, and we would never know without actually finding out this empirically. They can also actually inadvertently cause more hallucination by simply switching the words, rephrasing in some subtle ways. So this is clearly not going to be enough. So you need more than a prompt. Misconception number 2. Charge models do not need to be managed like the other LLMs because they are not as important, or they are kind of somewhere below the stack, and you really should be only concerned with the operational LLMs that actually power your product. Well, if you want to be serious about taking applications to production and you want to be able to use charge models in production, you not only need to manage them at least with the same level of attention and care as these operational models, but you also need to take into account various new factors. So in addition to things like size, cost, and latency, which actually now take a different kind of twist when you try to run a lot of these judgments potentially in real time, if you want to do that. And that will put another kind of strain still on the models that use your judgments, which is a bit different kind of dynamic than what you have with your operational models. And there might be different kinds of expectations for what is allowed latency, degree of latency for the judges. Moreover, the judge models are not scored based on what the operative output is. So they are not, the judge models themselves need to be actually evaluated in the way that you need to actually make sure that the numbers they're giving are consistent, they make sense, and they align with the human preferences. So they are essentially calibrated to align with humans, and they are tested in a very different way than the operative large language models are, or the features at the top level of your stack, which is what your application is actually trying to do. So these are very different things. One is in one case you are measuring what your application is really intends to do, so the actual business value, and on the other case you're measuring a system that tries to guarantee that you get that business value that you would like. So completely different performance requirements. And there's a lot more to say about this, but we will just leave it now at the statement that not only you need to pay similar level of attention to these different kinds of models, but also you need to treat them very differently, and you need a framework to manage the charge models that is you need a framework that is actually geared towards the charge model management as a separate thing from regular operational LLM management. Misconception number 3. If you're okay with the level of risk, then using LLM charge is just an overkill. Like let's just hope that the chatbots are doing the right thing, because we are sort of seeing that they seem to be doing what they're doing, and it would be kind of too much to add another model there to add all that complexity. And that's of course always a judgment call, but many people come to these conclusions for the wrong reasons. So firstly, by thinking that you only can rely on some kind of low level observability, or just being aware that there are certain inputs, certain outputs going to the models, to the chatbots, to your agents. When you go to larger scale, larger volumes, well, there's no way you're going to be able to actually keep track of that just by human eyeballing. And the reason people might think that you don't need this kind of complex semantic evaluations on those outputs of the models is often based on underappreciated understanding of how unpredictable the LLMs can be. So even if you might expect them to behave in a certain way, they might just not be. And whether this is critical or not, of course, depends on your application. So if your application is not that important to begin with, or accuracy is not that important, then of course you might be fine. But in most cases in business, it is really dangerous to just go out there without any kind of framework in place that is actually making these high-level judgments. So it's kind of the setup where you can reveal these unknowns by using the charges to actually look for certain kinds of things just in case, even if that never happens. So misconception number 4, that charges are there essentially to block unwanted responses. So basically, the misconception is about treating the charges as kind of binary guardrails, basically letting something through or not letting something go through. And this is kind of the classical guardrails approach. But if you think of this in more detail, firstly, many of these criteria that we use to make judgments are actually matters of degree. So if you consider like safety of a statement, like in the sense of like safety for work, safety for children, this is for sure some kind of matter of degree. It can get better or kind of get worse. If you think of things like relevance of an answer to a question, it's certainly a matter of degree again. And in order to actually capture this diversity of different cases, of course, you need a metric approach if you think about it. So there should be a sliding scale. And then you turn this into a guardrail by saying that, okay, if the safety is below this minimum threshold, then you block that content. And this is an important difference, because now if you use this metric approach, you can actually just keep optimizing things. But if you just have a classification based approach, then the optimization immediately becomes harder, and you need to kind of take it to the level of statistics, of having a large set of examples, and you're kind of wasting this opportunity to actually look at this more precise number that would relate to each sample. In addition, there's the recent trend where we are actually doing more rounds of LLM calls to begin with. So this again increases all kinds of risks that accumulate, and then you want to be even more precise on what happens on your first run before you move that content to the next stage, to the next LLM call. So you want to catch even these more subtle deficiencies on your output before they're passed forward on the chain. And what it means in practical terms, when we talk about metric evaluations, it looks something like this, which is a typical list of universal evaluators that come out of something like a root signals platform, where you're actually having some certain numbers for a certain input for truthfulness, relevance, clarity, and all that. And then you have a certain threshold that you use to judge if this failed, if you want to block it or not. So it really is as simple as that. But then we soon come to some other questions and misconceptions about the use of these metrics and why people don't want to use them in some cases. So misconception number 5, this we hear a lot. So when foundation models become stronger, then actually we are not going to need any more chances, right? Because one day they will just be free of hallucinations, they will be free of any other errors in their behavior. So we are going to all become irrelevant if we just focus on these evaluations and measurements, because measurements will always give a maximum number and it will be trivial, and we will all be fine anyway without them. Well, there's a few different aspects to this. So firstly, the premise that the models keep improving in these regards of certain evaluation metrics, that is certainly true, and we've seen this happening, and this is truly awesome that this is happening. However, even at the maximum level of performance of a model, which would essentially be some kind of AGI, there will always be a question of energy. So you would always want to carry out any kind of cognitive operation with minimum energy utilization, maximum efficiency. So there's an argument that there are always going to be smaller models that you can use. There are always going to be like smaller, weaker models that you want to use. And that's going to be the case for a long time in any practical situation. So those models will still have a lot of those problems, even if the best models actually have resolved them. And also we need to take into account that there's a whole lot more to measure than whether the model is hallucinating. There's also semantic measures that are not something that the foundation models as such are going to maximize. So when we come to questions like, is it going to talk about our competitor? So in this sort of situations, it's not at all obvious that no matter how good the foundation model becomes, is it actually going to behave in the way you want it? Because it might just not have taken that meaning in the same way as you intend. And finally, historically, when the models have improved, we have always moved the goalposts. So when the models have become more complex, more powerful, we've always given them more complex problems to solve. And so far, we haven't run out of complex problems to solve, so that the development will probably still continue, and hence the errors will sort of again begin to materialize when you move from simpler to more complex problems. And there's an argument to be made that actually the user charges actually enables pretty much anyone, especially smaller, less well-funded companies, to actually start creating judgments, creating mechanisms that were only previously possible for larger companies. So this is sort of we would see this more in a positive light than in the light of being somehow making the user metrics relevant. But actually, when the models become more powerful, it just means that everyone can make even stronger evaluations on any kinds of text. Actually, whether it's from LLM or from human sources, which is another interesting line of applications. And finally, when the models become stronger, the explanations that these charges give are actually also going to become stronger, more useful, more expressive, and that's also one of the things that we, for example, as rule signals, are putting more attention to, so that those justifications for the scores that the judges give are actually top-notch and really useful and interesting for the people who actually use them, and even making our own judgments potentially better when we can see sides of the problem that we didn't realize before the LLM was telling us and explaining its own line of reasoning. And at this point, we will move to some of more practical aspects of LLM behaviors. So our head of AI in root signals, Oz, is going to start from the next misconception. So Oz, please go ahead.
Thank you very much, Adi. Hi, everybody. This is Oz, head of AI at Root Signals. Super nice to be here. I'll be continuing with the next common misconceptions about LLM judges. And the next one in our list is misconception number 6, which is traditional metrics coming from natural language processing are enough. These are stuff like blue scores, rouge, cosine distances of embeddings, and things of that sort. These are not new, or at least variations and variants of that. And we realized actually in reality, these cannot capture the intricacies, the difficulties, complex nature, and slightly abstract nature of things people would like to actually measure when they are developing LLM applications. In reality, these metrics, or even lower level metrics, they are not very useful. But not only that, but in fact, they are misleading. There are a bunch of libraries and tools out there. When you go them, first thing they show is Blaze score and Rouge score. And if you're not coming from machine learning and NLP background, it immediately implies that, oh, this is something I should probably try to maximize because it seems relevant. But these kind of metrics, they are working in super simplistic way. They measure word matches and n-grams and word counts and things of that sort, or cosine distances, vector embeddings, things of that sort. They cannot capture actual complex intricacies, nature of the things you are trying to measure. And secondly, most of these metrics actually they require a ground truth, so they cannot be used without a reference, which is another drawback of these metrics. But I'll be super concrete. Let me give you an example. Let's try to imagine we are comparing two texts. It can be ground truth based thing, or it can be similarity based thing. We would like to get the similarity of two pieces of text. The first text is male tennis player jumping off the ground and swinging racket in front of an audience. And the second text that we are trying to compare is a young lady dressed in white playing tennis while the ball girl receives a tennis ball behind her. Now, are these sentences similar? Well, depends on the context. Like if you run some similarity search, a similarity comparison, such as um, cosine embedding, cosine distance, you will get some score. It's kind of relevant. They're playing the same thing, and there's racket and ball, and the semantics are similar. But in reality, you want much complex, much more constrained definition of context. So, for example, are these sentences similar in the context of the sport being played? Yes, very much so. They are both talking about tennis. But are they similar in the context of number of people involved? No. The first one, there's only a single person, and the second sentence has two sentences. And this kind of measurements you can only implement with another LLM. In other words, LLM as a judge. Next misconception is LLM judges make sense only for A or B comparisons. And what I mean here, A or B comparisons is this response or output better than this other response? So most people think this is the only way, this kind of reference way, or this kind of relative way is the only way to utilize LLMs as judges. But this is a misconception. And in reality, judges can perform, in fact, absolute judgments when designed properly. And what I mean by designed properly, when you tune them properly, when you give the proper instructions, either in the prompting way or in context demonstrations and examples, when you give a rubric, this is the grading system I would like to have, they can perform quite well, actually. And one of the reasons why this misconception actually is prominent is mostly this stems from lack of appropriate tools for tuning LLM judges and evaluating LLM judges. In other words, meta evaluation, evaluating the evaluators. When developers and AI engineers and data scientists and software developers, they do not have the appropriate tools to actually create and tune these judges, then it results in a misconception that the LLM judges cannot judge in absolute terms, and it can only judge in relative terms, and this is wrong. And that's we are heavily focused at root signals about the ability to tune and evaluate and manage all these judges. And secondly, these judges, of course, have biases. For example, verbosity bias. They tend to evaluate long text much higher with much higher score than short text, and they have position bias and confirmation bias and things of that sort. Because people don't know how to measure and unbias these judges, they also jump to the conclusion that judges only make sense for relative comparisons. But this is not actually true. Misconception number 8 is you always need a human in the loop. A human in the loop is always needed for all sorts of use cases. This is a misconception. It actually, of course, as many things in life, it depends on the use case. Now, there is quite some research, and this is one of them. It shows that a properly tuned and instructed LLM judge has quite a high agreement rate with human judgment domain expert judges. In fact, the agreement rate or disagreement rate, however you want to call it, between the judge and the human is pretty much the same as the agreement rate between humans, because there's subjectivity between annotators, even they are both domain experts, there's some variation, and that level of variation is in fact the same between a human and an LLM judge when the LLM judge is paired properly. And once again, this misconception stems from the lack of tools, easy to use tools to tune these judges properly, which we provide at Root Signals. And I would like to also a bit provoke everybody here. If human in the loop is needed, human verification and human evaluation is needed in every single thing we are trying to automate, what is the whole point even? Because the goal, the end goal of this technology is we would like to end-to-end automate certain tasks. We are not trying to still do the same tasks but 10% faster or 20% faster. Sure, maybe we start with that, but we would like to end-to-end automate things. And end-to-end automation is scary. You should be able to measure that. That's why root signals are here. But if we cannot, if human evaluation is always in the loop for all kinds of use cases, it will still be the bottleneck, because human evaluation it's expensive, it's time consuming, it's not standardized. Domain experts are hard to come by. Next misconception, it is the misconception that this is actually one of my favorites. LLM judges are only for developing things. They can be utilized for development. When you are developing your LLM applications, automations, and agents, you use these metric judges to measure. So you arrive and converge at the right solution quicker with more confidence. Well, that's true, but that's not only for only pre-production and development time. And there are a bunch of reasons for that. And the reality is you can use and you should use LLM judges also in production as live guardrails. Now, there's a great paper actually I'll be mentioning in a minute. It shows that, and we also know this empirically, almost everybody knows, but the paper quantifies it. It's a paper from Nature. LLMs can perform pretty complex tasks before being flawless in very simple tasks. And this has a very important consequence. And the consequence is that you cannot draw a boundary or a threshold and define this is the safe, reliable zones for LLMs. It just doesn't work like that. They can do really complex reasonings and things of that sort and still fail in super simple tasks, meaning that you have to one-off evaluation during development is not enough. You actually have to measure and monitor LLM automations all the time with low latency at scale with these judges in production, because as Ari also mentioned, this technology is inherently unreliable and unpredictable. It is just how it is. And I would like to also emphasize this paradigm is even new to machine learning experts and some data scientists who are not maybe well versed in generative AI part. So because in traditional machine learning, evaluation is of course extremely important, but it's not really a problem, because traditional machine learning, or maybe not traditional, but let's say discriminative models, meaning non-generative models, well, there are text classifiers and image recognizers and things of that sort. You can basically calculate ratios and proportions to measure your text classifier. It's just accuracy. It can fail only in these specific ways. So in traditional machine learning evaluation, you have a test set and you train your models and you calculate your accuracies and precisions and recalls or sensitivity or specificity or some computer vision related metrics and things of that sort. And if it is performing good enough for your use case, you go to production. There's no such thing as live production evaluation. There's no such concept actually. It's not very common because um, you have established the decision boundary and the reliable zone with non-generative models because they are working in expected ways. Even if they make mistakes, they fail in expected manners. So you have much more control, or your expectations align with that. But generative models, as I mentioned previously, it doesn't work like that. And this is the paper actually from Nature. It's a recent paper, and it sums up what I mentioned greatly. But there's a even more interesting fact. Is I would maybe call it a bummer. The fact is that more instructable, larger, more smarter models, they are actually less reliable. So all these GPT-4s and Anthropics and all these foundational models, they can do pretty complex tasks, but they are even less reliable. It's even harder to draw the decision boundary. Hey, these kind of tasks, I can just rely on it. It just works all the time. You cannot do that. So bigger models, they are less reliable. More powerful models are less reliable. This is quite counterintuitive. And many practitioners or even researchers deep versed into AI do not know this actually. Um, for my final misconception, we hear that this one quite a lot. It's the following. The misconception is that you always know what to measure from the get-go. When you build an LLM application, a chatbot, a summarizer, a metadata extractor, a translator, or some agentic system calling bunch of things, from the get-go, you know what to measure, so you can define, you can write a prompt to an LLM, turn it into an LLM as a judge, and you are good to go. And reality, I wish it was like that, but it's not like that. Reality is you create a judge, you create a system. First, you create an automation powered by an LLM, and um, you literally have to observe and measure how it works and where it fails. Then you create a custom judge or a judge provided by, for example, root signals well tuned to perform that specific evaluation, such as hallucination detection or answer relevance evaluation or tone of voice or groundedness or helpfulness or politeness or confidentiality leaks or things of that sort. And you cover a bunch of areas that you care about. But then you realize, oh, the model is outputting also this sort of attributes. Maybe the model is a bit too chatty. You realize in production, because these are promptable systems. People prompt in certain way, the world changes, new models come, the way people interact with these applications, the UI and UX even changes, and you realize, oh, actually, I should also care about this other attribute. Let's say maybe conciseness. You don't want the model to be too chatty. Um, then you realize, oh, every now and then when I interact with this application powered by an LLM, it tends to a bit go off topic. I should probably define a measure to detect that and observe that, so that first of all I understand why it happens, I understand when it happens, and I can catch it also in production before showing to the end user with my LLM judges deployed at scale live. So my point here is LLM judges, they cannot be treated as one-off static artifacts. Oh, it's just a prompt and you are good to go. They are live things. Just like your actual automations you've built. You want to tune them, you want to observe them, you want to measure them, you want to train them, optimize them. You have to treat LLM judges, meaning the measurement devices, the same way. If the measurement device is obsolete, if you cannot rely on it, if you cannot trust it, what's the whole point? So LLM judges need to be tuned, you need to be measured, optimized, they need to be version controlled. What kind of data goes into your judges and how does it perform? What are the decision boundaries? Where does it fail? What is the latency? What is the cost? The whole shebang. Now, the fact is that if you try to implement this and manage this whole evals and measurements and LLM judgment landscape yourself, things get chaotic really quickly. You don't want to deal with a bunch of Jupyter notebooks or Python scripts and some data is there and no version control and some prompts and how did I tune this? What did it go? Where are the results? Can I compare last week's result or new data came or somebody changed the model? It's a mess. You want a principle, systematic, grounded, future-proof approach to manage your LLM evaluations, your generative AI evaluations frameworks. And that's why we are providing that, we are building that with root signals, and our customers are enjoying that so that we ease their job for measuring their LLM automations at scale, mostly with LLMs as judges. All right. Thank you very much. This was Oz, head of AI at Root Signals, and we talked about 10 common misconceptions about LLMs as judges and tried to hopefully clarify how can you avoid these misconceptions, how can you mitigate this sort of misconception consequences, and we would be happy to answer your questions if we can right now with Ari. Thank you.